Hey everybody, good afternoon slash morning. Okay, how do I know if this is working? Can you guys hear me okay? Mm. Sweet, excellent. All right, so I'm gonna wait a few minutes before I actually get started. We'll see if other people join us. Excellent, you guys can hear me, perfect. Just getting used to that delay is gonna be a little bit strange, but yeah, we'll figure it out. That's my browser window. That's my processing window. Yeah, so we'll use a few minutes. I'm gonna ask you some questions. If you can answer in the chat so you guys can hear me. If the text is okay as well, that'd be great. If this is something you can read, let me know also. The code webpage is live, so whatever I'm typing in here is going to show up on the code webpage as well, just like in class. Or at least it should. Let's check. Yep, that works. Cool. Hello, Cheyenne. Cheyenne, sorry. Sweet. So let's see. Okay, so we got a few people. Excellent. Hello. Okay, so I guess the way we're going to do this is I'm going to run through some examples, and if you have some questions, you can try to use the chat to ask them. So I have the chat window open right next to my processing editor, so I should be able to see, try to catch some of the questions if you have any, and we'll take it from there. And yeah, please excuse the white ball of light up there. That's my window. There's nothing I can do about it. Yeah, so the plan today, let me use this to put out some notes. We're going to go over a few things. We are going to, first we're going to do an example around ArrayLists. And I want to talk about how to remove objects from ArrayLists, because that's something a lot of you are going to run into and when you try to program your games. And we didn't really do an example of that. So we'll talk about adding things to a list and then removing objects. So if you're trying to program a game where you're shooting some enemies or you have some targets you need to get rid of, this would be the technique how to do it. And there's a couple of little things to be aware of once you try to do that. So we'll do an example around this, and then we're going to switch to talking about libraries in general. I'll show you a few things that, even though we've covered libraries already, I'll show you a few things I have to do with libraries, and then specifically I'll do some examples around one library that I use all the time called ControlP5 for GUIs, or graphical user interfaces, and then we'll look at Fisica, which is a fun little physics library. And yeah, we'll do a few program examples around those libraries. They may or may not be useful for your games, but those are also good to know for just in the future. And when you try to use processing in your future projects, just getting to know the libraries really pays off, because you can do a lot of really cool things really quickly, because you don't reinvent the wheel every time. Instead, you're building on top of what other people have already figured out. Okay. Alrighty. You guys ready to get started? Somebody could say yes in the chat. I will get started with the first removing things from array lists. C, perfect. All right. And also, before we start, if you did not make it to meta for whatever reason last night, you should really thank you, Maida. You should really try to make it out this weekend. It's on for the next 3 days. Some really amazing projects on display this year from graduating class. It's well worth the little detour just to go check out some of the things students have made. And if you post a selfie to the bonus point assignment, you'll get a bonus point as well. So, of course, a selfie of you at meta, so I know you were there, if that makes sense. Okay, so first example we're going to talk about removing things from array lists. And in order to be able to do this, we need a program. So we need something to play with. So I'm going to write a quick sketch here so we have something to work with. So we're going to need an array list of something. So I'm going to write a simple ball class, something we've done before. We're going to give the ball object an XY field and a speed X, speed Y, so we can animate it. And for this example, I'm going to create balls that are going to fall from the top of the window. So they're all going to start at 0. They're going to have a random speed on the x-axis, and on the y-axis, they're going to be going down. Okay. And then we have some code where we will tell our balls to move. We're going to add the speed to the position. And if we reach the left or the right edge, we will turn around. And then we'll get back to y in a second, the y coordinate. We'll have them bounce up, and then we'll do a little gravity trick as well. Some of you have figured this out when you did your exercise 7. And that's just going to be an ellipse. And actually, they need a size as well. So let's give them a radius. We'll make it random for fun, between 25 and 50. And it's a radius, so we'll do ×2 here. Okay, so this is just a quick little class here, so we have something to work with. It's going to just create some circles that are going to fall down from the top of the window. We can test it real quick to see that it works. We will say, make a new object from our ball class, and then move and display it in draw. Now I'm going to run the code, and this is what that looks like. And we can't really see the outline of the window actually, so let's make it a gray background. All right, that's better. Let's make it fall down a little quicker. Okay, so these guys are falling down, and this is just so we have something to work with. And then just for fun, we're going to get the circle to bounce when it reaches the bottom edge here of the window right there. So we'll tell it to go back up when it reaches the bottom. So the way we're going to do this is we'll say, if we reach the bottom, if we reach the floor, we are going to make revert speed Y. Now a neat trick we can do here is we can kind of create the illusion that there's some gravity going on by saying, instead of just making the speed equals to sorry, -1, I meant to say here. instead of just reverting the speed, so it just turns around, we'll make it so that over time, the bouncing is going to, the circle is going to lose a little bit of speed over time. So instead of 1, we're going to do like 0.8, let's say. So that means when we fall down, it's going to bounce up. Oh, it's getting stuck here a little bit. So we'll say, let's move it to height just to be sure it doesn't get stuck. So it's going to lose a little bit of speed. The way if you drop something on the floor and it bounces up, some of the floor is going to absorb some of that speed. And then we're going to pretend that there's this thing called gravity in our world, which is just going to be a constant amount that we're going to add to the speed over time. So in move, we're going to add a little bit. So that's going to become the gravity. And the idea is that if you have something up in the air and you drop it, you'll observe really quickly that the speed is going to increase over time. So what we're doing here is we're modeling this in our program. We're saying this 0.05 here, it's the pull down of the gravity. It's saying regardless of what speed y is, just increase it downwards, so to simulate gravity. And because we're adding in every frame, that gets faster and faster. So this little plus 0.05 here is kind of pulling our circle back down, even though when it's going back up here, it's constantly adding a tiny little downwards force, and that causes it to just bounce when it reaches the bottom of the window. Okay. All right, so the point here is not so much that bouncing circle, but what I want to do is I want to then I just wanted to create something that we have we can play with. So now we have this ball class, and we can make ball objects. So from there, what we'll do is we're going to create an array list so that over time we can add more objects to our program. And then I'll show you guys if you want to remove objects from the list. And we can do something really simple where we're going to click on them. I'm going to make it so that if I click on those circles, I'm going to be like popping the balloons, so to speak. And we'll see how we would go about removing them from our program. And that idea you'll be able to translate probably to a lot of things you're all trying to do in your games. All right, so the first thing we'll do is, because we're talking about array lists, we're going to change this. We don't want to have a single object. We're going to create an array list of these ball objects. We want to have lots of them, and then we'll worry about figuring out how we click on them, and then we'll worry about removing them from the list. So this is going to become an array list. So first, this is the type, right? Array list, and then we add the kind of object we want to put into that list. So that's going to be an array list of ball objects, and I'm going to call it balls new array list, like so. And the neat thing about array lists is that they allow us to create arrays that can expand and shrink as we need to. So it starts out empty. We don't have to decide how many objects we want in there. It's just an empty spot where we can start to add objects over time. So for instance, we could say in mouse, like key pressed, we're going to add them on the key press just for making something a little different here. We'll say if key equals A. So if I press the A key, I'm going to add a new ball. So let's say first we're going to take our array list, then we'll say add, and then we'll create a new ball object inside the parentheses. So that little bit of code here is going to result in a new ball object that will then get added into this array list. Okay. So whenever I press a key, if the key is letter A, then I'm going to add a new ball object to the array list. And the last thing we're going to do is now we broke the draw function because we got rid of this single variable. So what we want to do is write some code that will say, go through this array list. And for each object that is inside the array, I want to be able to move it. And I also want to be able to display it. And we're going to use the shorthand for loop syntax to do that. So we'll say for every ball, and we'll use the letter B as our variable because it's already down there, and I'm lazy. Inside the array balls, we'll say move and display. So this is a nice compact kind of shortcut for loop. Whenever you want to go through an array list or an array of objects, and we're not interested in the index, we just want to cycle through all the objects. And if the array is empty, that's fine. It's just going to skip over that code altogether. So let's see what that looks like when I run the sketch. So in the beginning, I have nothing, and then I can press the A key, pressing it loudly so you can hear and see that I'm not lying. And so every time I press A, it's adding a new ball down here, right? So it's saying add a new ball to the array list. And as this array list expands and grows, this for loop has more work to do each time. Right? So when it only had one ball, it repeated once. Now I have 5 of these, so this for loop is repeating 5 times. And if I add a 6th one, this for loop is going to repeat 6 times. Okay? So it's a really compact little way of saying, go through every object that you have inside this array list. All right. So now we have something to play with. So maybe we are creating, I don't know, some kind of game where we have to catch those and pop them or something. And we need to be able to say, well, first, when we click on the circle, we want to be able to detect that. And we'll see this is just a simpler version of the collision code we did for the game. It's super straightforward. And then once we know this, what we need, and that's really the point of this example, is we want to be able to remove objects from the array list. And if the intention here is if we can take out an object from the list, it will essentially disappear from our program, because if it's no longer in here, it's not going to get moved and it's not going to get displayed. So it will just be gone. And that's what we want to do. All right. First, let me check. Cool. Okay, we have some more people. What's up, guys, who joined since the beginning? And okay, you guys following all right? If somebody could say something in the chat, that would be great. Just anything, so I know that you're still there. I'm still getting used to this talking to myself idea. Awesome. Thank you, Priyanka. All right. Where's my processing window? Okay. So let's try to do this. So the first thing, thanks, Paul. First thing we have to do is, thank you, Joe, is let's figure out how we would, all right, let's figure out how we would tell if we clicked on one of those circles. So we're going to add the mouse press event, because we want to respond to, only want to check if we've hit a circle when the mouse gets pressed. So the task at hand here is kind of like with the collisions between circles, except it's simpler. Okay, we want to see, okay, we know the position of each circle. Each circle has an XY coordinate. These are the 2 fields inside the class here. And we want to know essentially if when we click, if the mouse cursor is within the circle or not. Okay, so when I'm clicking around, I want to be able to tell, is my mouse cursor inside the circle or outside? So the first thing we're going to do is we're going to measure how far away we are from the center of each circle. So we're going to take a measurement using the distance function, and we'll say measure between my cursor and the circle. Much like in the game we did, we measured between the 2 game objects. So we'll say check all the circles. So we're going to write a for loop. Now here, I'm not going to use the shortcut syntax, and I'll explain why in a minute. But I'm going to write more a kind of a traditional for loop, and I'm going to write it like this. I'm going to say for every, it's called size. So an array list doesn't have a length field, but it has a size method, which does the same thing. It just tells us how many objects are currently in this list. So now we'll say count from 0, right, to the number of objects, and we can use I as an index. to get the objects out of the array. Now, because it's an array list, we cannot use the square brackets like we would do with an array. Instead, we use the get method, and it does the same thing. So this is going to pull up an object from the array. And then we're going to ask the question, are we clicking on this ball? So first, let's measure the distance. Step 1. And we'll say distance, it's the distance between mouse X, mouse Y, that's where our mouse is, and where the ball is, which is BX and BY. So that's going to give us a measurement in pixels. And then we can use that to ask the question, are we inside the ball? Which really means we know the radius, right? So just like when we did collision between two circles, when we had two circles, we were looking at the sum of their radius to see if they intersect. Here this is easier. We have just the one circle. We just want to look at if the distance, right, is smaller than the radius, then the mouse cursor has to be within the circle. If the distance between the mouse and the circle is greater than the radius, then we're outside. So it's a simple if statement like this. We can say if the distance is smaller than our object's radius, then we know we're inside. Okay. So at this point, what we want to do is we want to take that object, ball B, and we want to remove it from the balls array. So we can say balls dot remove B. Take it away. Okay. So let's see how that works when I run this sketch. So now I can add some ball objects, and then if I click outside, nothing happens. If I click on them, right, we find that the distance is smaller than the radius, and if that happens, that gets removed. Okay. And if two of them are overlapping, they will, oh, that almost happened. Just gonna add some more. It'll take away all of them, right? So now I can have objects come and go, and I have a way that I can actually remove them based on a condition. Now the trick here is we had to use this style of for loop. The reason for that is when we use the shortcut syntax up here, we cannot change the list or the array list as we iterate through it. So we don't want to be adding stuff to it or removing things from it. We just want to iterate through what's already there. As soon as you're going to be adding or removing objects from the array list inside a for loop, you cannot use the shortcut syntax. And the shortcut only works if the array doesn't change while the for loop is running. So you don't want to change either add or remove objects as this for loop runs when you use the shortcut syntax. So up here it's fine because all we're doing is just go through all the objects and then move and display them. Okay. Down here, because we know that we might remove objects from the list, so as we're going through it, we might be pulling things out. So the way that we can do this is then we're going to iterate just like if it was a regular array, and by generating an index using I, and then using that index to pull out objects one at a time, and then we can do whatever we want with those objects, just like, we would do with a regular array up here. So just something to keep in mind. So if you're going to be messing with the array list, either adding or removing as you iterate, you cannot get the benefit of this like short syntax. So we gotta just do it the long way, which is not that much longer. It just means you write a for loop like this using an index, and then you pull out the objects using get. These two lines here kind of all happen at once in this shortcut version. So small price to pay, because now we can actually remove objects as we're going through it, and this is very useful for games, as you can imagine. Cool. So all of these examples I'm doing today, by the way, they all posted to D2L as separate programs. And let me just make sure my code web page is still working, in case some of you are trying to follow along. Yeah, still good. Excellent. Okay, so that was the first example I wanted to do, just talk about removing objects from ArrayLists, because you will many of you will run into this, and now you have a way to do it, and you won't be stuck on that problem forever. So let's switch gears here a little bit and start talking about libraries. So I'm going to get rid of this program, and again, if you didn't have time to grab it all, they're all posted on D2L, so it's no big deal. I'm going to close the processing sketch. Okay, so libraries, not a totally new idea, but we've kind of skimmed over that concept a little bit. The idea behind libraries is they're pieces of, they're mostly collections of classes that other people write and then share to the package in this package that's easy to add into your program. So when you install a library, what you're doing is you're extending what processing can do by adding some new objects and classes to it that other people have already written, so you can use them in your own code. So they're like a plugin, right? Except because we're in a programming environment, the plugin comes in the form of new classes and objects that you can use, and primarily it's mostly list new objects. So let me open up the browser here. Okay, so I'm on the processing web page, and there's a few ways that you can know about which libraries are available. We've already saw the library manager inside processing. There's also this page on the processing web page called libraries, and that takes you to kind of this list that's pretty up to date, I think, as far as I know. And you'll see there's two categories of libraries. There's the top ones at the up here. This cluster of library, PDF export, serial, video, sound. These are the core libraries, which means they're developed and maintained by the Processing Foundation, which is a not-for-profit organization that is keeping processing alive, basically. And it's a bunch of people who are volunteer their time to contribute to the software. And these ones are sort of part of the core, which means they get upgraded whenever processing gets upgraded, and you can kind of depend on them always being there. Okay? And this page is nice because it gives you an overview of, because you can read the little descriptions, it gives you an overview of all the different things you can do with libraries. Okay? So after the core libraries, then there's what's called the contributed libraries. And the contributed libraries are basically libraries that were developed by the processing community. Just people who use processing in their work. Maybe they've made something interesting and then decided to package it as a library so that other people can benefit, and shared it with processing so that it gets listed on this page. There are more libraries out there in the wild. Just, there's nothing stopping someone from just creating a library, putting it up on their website. The one thing that all these libraries have in common is that in order to be listed on this page, they have to meet a basic standard. So they have to work. They also have to have some kind of documentation, some number of examples that come with them. And yeah, so there's a bit of a filter that happens. There's a volunteer person in the Processing Foundation who only looks after libraries and receives submissions for new ones, and kind of makes sure that the collection is this at least of a certain level of quality. Okay? So you've got all these different categories. As you can see, there's lots of libraries for processing that kind of expand what you can do with just the basic set of functions that we've looked at in this class, which is primarily focused on drawing, right? Because processing has this sketching metaphor, and a lot of things have to do with drawing and learning how to code while drawing things. But of course, it's a full-fledged programming language. You can do way more with processing than just drawing little things. There's libraries to deal with, data, interfacing with hardware, doing computer vision, video, all kinds of physics simulations. Lots and lots of interesting libraries for doing animation, 3D, all kinds of stuff. Now, of course, we don't have time to cover all of these libraries. So what I thought I would do today is just give a few examples with two libraries that I think are very useful to have in your toolkit. And as we do that, we can also kind of talk about concepts that tend to apply to most libraries. And they're all a little bit different. Once you kind of venture in the world of libraries, you have to expect um, a different level of consistency compared to the core processing ones. So for example, the core processing libraries, if I look at the sound library, like the reference page matches the aesthetic of the reference page for the rest of processing because it's all part of the same package. When you venture out into other libraries, then the author of the library, makes some decisions about naming of functions, how things are organized, how the documentation is formatted. So you can expect like a wide variety of styles and different ways of thinking about things, which is nice. But it also means you have to uh, take the time to sort of read the manual, so to speak, before you can use a library. Just look at some of the examples, look at some of the reference pages. The first one we're going to look at today, just to show you how it can be pretty different, is this library called ControlP5 over here, developed by Andreas Schlegel. This is a library to build user interfaces. And so let's take a look. When we follow this link here, it takes us to the ControlP5 page. So you can see already, there's a totally different aesthetic from the processing website, because that's, Andreas's library. He made this page. This one has particularly good documentation. So it's very thorough. Not all the libraries will be so thorough. So sometimes you're more on your own a little bit. But ControlP5 allows you to create things like this. So you can add, a variety of sliders, buttons. It's a very complex, pretty deep library, but we'll see today we can use it for doing simple things as well. And it can be pretty useful when you're. I've used this library in every single project I've done with processing in one way or another. So his documentation page is formatted differently. And the most important thing I want to point out is once you move into the world of libraries, probably the reference pages will come in the form of this thing called JavaDoc, which we hinted at in the last class a little bit. JavaDoc is this standard Java way of creating documentation for objects, and it looks like this. It contains similar information to the reference page in processing. It's just formatted differently. So this JavaDoc here is telling us that when we install ControlP5, we get this whole collection of objects. So this is a big library, starting with this ControlP5 object. And this page on the right is telling you what these objects can do. So you'll have fields. This one has a little example on how to use it. And then it has the methods, which is the thing that you're most interested in. The methods are all the things that the object can do. And it's formatted differently than the processing reference. But this is where you'll know how to use the objects. And there's short descriptions. So you have to kind of do your homework when you're starting to use a new library. Mostly you would start by kind of dissecting some of the examples and then going back and forth with this, using this reference to sort of look at what the different methods are for. And if you click on one of them, it sometimes takes you to like a slightly more detailed version. So the bottom line is the documentation pages will look a little bit more intimidating with libraries, but the same kind of information is there. You want to look for what are the methods of the objects in the library, so you know what you can do with them. So for example, if you create like a slider in ControlP5, once you have a slider, what can you do with this slider? Well, you would have the list of methods. These are all things that this object is able to do in your program. All right, enough of this. Let's do a little example of hide that. Let's go back to processing. So before we can use a library, we have to install it in processing. And the easiest way to do that is to always rely on the library manager. Interesting. I don't think you guys can see my menu because it's weird. Okay, well, just go under the sketch menu, import library, add library. We've done this before, and I did not plan for this. Let's see. I'm going to add this as a new source real quick. Just give me 1 second. Okay, that should appear now. That is my library manager. And it's under sketch menu import library. I don't know why the menus don't appear. They don't seem to appear on my preview window, but I'm sure you can figure it out. So here you have just a more compact version of the list we had on the processing website. This is another place where you can browse. I prefer to browse on the processing page because it's easier to read and it's categorized into the, so it's a bit easier to manage. But once you want to install something, you do it from here. So we're going to search for ControlP5. I already have it installed. If you didn't, you would click on the install button and that would bring ControlP5 into your sketch, just like the way we installed the sound library before for the game and the video library. And then once you've done this, you're able to go into Sketch and click on Import Library and then select the library from the drop-down menu, which for some mysterious reason doesn't appear in the stream, but you know what that looks like. And when you do that and click, all it does is it just adds this one line of code to your sketch. That will be different for every library. And this is Java syntax that says, go into this package and bring all of the classes and objects that are in there into my program so I can use them. So this is importing this external library. Let's do a little ControlP5 example. I'm sure there's no question in the chat. Okay. Give ourselves a window size. So this example, I'm going to keep it very basic. What we'll do is we'll start by, we're going to create a slider that's going to allow us to change the color of the background of my window. Okay? So in order to do this, we're going to make a variable that's going to control the background color. And we'll keep it very simple, just a single number, BG, not FG. Okay. So if I put 0 in there, I'll get a black background, and if I put 128, I'll get a gray background, and so forth. So if I want to use the ControlP5 library, the first thing I need to do is create a ControlP5 object. I'm going to call it GUI, and you'll see that a lot of libraries follow that model, where they're going to have this kind of like a master object, where you will only ever create one instance of. So I only ever need one ControlP5, and a lot of the magic for the library is going to happen within that object. So it's kind of like the puppet master for this whole library. And this, this kind of master object is going to manage and control all the other objects that we will create from the library. So that's a very common pattern that you're going to see in a lot of libraries. They will have created some kind of master object, often will have the same name as the library itself, and the expectation is you only need to create one of those. So here we'll say new ControlP5, and then this ControlP5 object wants one parameter, which is the keyword this. And we've talked about this before, but this is worth kind of explaining again, or at least pointing out. So the keyword this in that context here means our sketch. So if we were inside a class and we wrote this is this introspective little keyword that allows an object to refer to itself. And when we write a processing sketch, the thing that we're not aware of necessarily is that the processing sketch itself is an object. It's just the class that we're writing within is hidden from us by processing. So it just kind of shows us set up and draw, but all the things we're creating here, they're all part of this big class that represents our program. So when I say this here, it's a reference back to the sketch itself. And a lot of libraries will need that reference in order to be able to go and control things in our program from behind the scenes. So this creates a connection between our program and the library object. So it's like we're passing a handle or a reference or a way for this library to kind of be able to tinker with our program behind the scenes. So a lot of libraries, when you create them, will require you to put the keyword this somewhere, and that's as a parameter. This, if you look at the documentation, this is going to refer to a p-applet, which is the class that we're writing when we write a processing program, the sort of all-encompassing class that we don't get to see. This is actually a p-applet object that we're currently writing without knowing it. So this refers to the p-applet, which refers to our program. All right. So, and then we'll see that once we add some objects to this library, because it has this connection, it's going to be able to draw things within our window just by itself, essentially, without us having to do anything, which is nice. So let's do something simple. We're going to add a slider. So this is it's a very deep library that has lots and lots of objects you can add, like buttons, checkboxes, color pickers, knobs, text fields, all kinds of things. You can create, layers, different windows and panels, and all kinds of elaborate user interfaces. We'll do a very simple example today. We'll just add a slider, and then later on we'll add a button. So it's possible to also use that library in a very simple way. So one of the nice things about ControlP5 is that you can connect these interface elements directly to variables in your code. So for example, what we're going to do here, I have this variable called BG that controls the background color of my window. So what I want to have is some kind of slider I can move back and forth that's going to change the value of this variable. So what I'll do is give the name of my slider, right? I'm going to call it the same as my variable. And because ControlP5 is a magician, it's going to be able to connect these two things right away. Then we're going to specify what's the range for this slider. So it's going to go from 0 to 255. And that can be any numbers. You can have any kind of range that you need. And then we're going to give it a position, actually. So the parameters, right, in that order is going to be the name, the min, the max, the x, the y, the width, and the height. So I'm going to give it a position. I'm going to put it in the top left corner of my window. And let's say we're going to make it 200 pixel wide and 20 pixels tall. So just by adding this line of code, the ControlP5 library now goes and creates this slider over here. And it has a name, which we can't see because the name isn't white. But now I have this thing I can control. And I can move this slider. And the text is very small, so it might be hard to see on the stream, but you can see the value of the slider on it. As I slide it, it goes from 0 to 255. And next to it, it has the name that's being put in all caps here, BG, with this font. So now I've created a little user interface element that I can use to control a variable in my sketch. And we had to do very little work to do this because this slider element is a part of the library. So it really pays off to get to learn some of these libraries because you can do cool things without having to lift a finger, essentially. You just have to learn how to use the library, and then you can do more interesting things much more quickly. So this slider now allows me to go from 0 to 255 interactively, and that changes the value of this variable automatically, which is cool. And its starting value will be whatever my variable was set to. So here I've set it to 128, and ControlP5 knows this. It makes 128 be the starting value. So I like using these sliders if only to, whenever I write some kind of program or some installation using processing, I'll have some quantities in my program I might want to be able to tweak on the fly. So those might be like parameters that affect your, let's say you're making a game and you want to change like the overall speed of the enemies or the rate at which the enemies are appearing or various things. And kind of like with tweak mode, you don't necessarily want to have to turn off the program, go change the code, turn it back on. You just want to have some more immediate control over what happens. You can create your own set of control elements so that you have an interface to your program, and that can be a very useful thing to do. And then you can hide that interface. You can tell it to hide. I said GUI.hide here to make it disappear. And there's another command called GUI.show that makes it appear again. So that could be controlled by the keyboard, for example. So those controls can be brought in and out of your sketch to tweak things, and then when you want them to go away, you can hide them. So that's very useful. The other really neat magic trick that ControlP5 has up its sleeve is that, so it can create sliders and knobs and checkboxes that control variables directly. A checkbox would control a Boolean variable, right, true or false, and a slider or a knob would control a float, a number. It can also be used to create interface elements that will trigger functions, that will create events, basically. And that would be something like a button. So when you create a button and you click on it, you can have some code run whenever that button is clicked. Just like we have the mouse pressed event and the key pressed, except this time it allows you to create code that only runs when a specific button is clicked. Let's do an example of that. I'm going to add a button, and I'm going to call it pump. And this button, so the value of it is going to be 0. So the parameters, these you would find out, of course, by looking at the reference page, but I don't want to go back and forth. So I'll just put the reference as a comment for you that you're trying to follow the code here. We'll put a value of 0 because we don't care about the value, and then we'll give it a position. I'm going to move it, going to put it below my slider that I just made, and we're going to say, let's make it 80 by 40. Let's see what that looks like. All right, that looks pretty messed up, so we're going to move it down more. I meant to do 20 and 50. Yeah, that's more like it. So now I have this button, and I can click on it, and you can see it changes color when I click on it. It also has a rollover behavior. So all of this is, it's programmed inside ControlP5, but we get all these cool behaviors for free, basically, just by learning how to use the library. Now this button doesn't do anything, so what we're going to do is create some code that's going to run every time we click this button, and we'll see it's very easy to do. The other thing to point out about ControlP5 is that right now it has this blue color scheme, and the text uses a particular font. Like all of this, you can also, if you learn to use all these objects, they have methods where you can configure their colors and change the font that's used for the text. So all of this is, you can get pretty deep in like the level of detail you want to configure this, but when you just use it like this quickly, it just uses some default colors and fonts and all that. Okay, so just like with the slider, the way we connected it to a variable is we just use the same name as the variable. So when I create a button, if I want to connect it to some code, I'm going to create a function that has the same name as my button. So my button's called pump, so that's going to become a function called pump. Okay? So that's my button event. Right? So the idea is that all I have to do is give it the same name, and ControlP5 will know to run this code, whatever we put inside this function, every time the button is clicked. And that's just going to happen automatically. So let's add a variable here. Let's call it diameter. And we're going to use that to draw an ellipse, whatever color that is, just so we can see that our code is working. So we'll just draw an ellipse in the center of the window, like so. Okay, I got this little green circle here in the center of my window, and every time I click the pump button, we're going to put some code inside the pump function. It's just going to increase the diameter. Let's say we're going to increase it by 10. That's just the way that we can see that it works. So now when I click pump button, you can see that this circle is getting larger because this diameter is increasing, and that's the value that I'm using for the size of the circle. Where did my window go? Cool. So this is really neat because it's very easy to then create a range of buttons if you want to, and then if you want to connect them to some code, all you have to do is be consistent with the names. So if I call the button pump, the function gets called pump. If you want a slider that controls a variable, the slider is called BG. It changes a variable called BG in my program. So already just with these two elements, you can create all kinds of really useful little interfaces for your sketches or games if you need to add these kinds of controls, and then you don't have to program them from scratch, which is nice. Cool. All right, let's take a peek here at my code page. Mixer is still on. Yep. So there's of course a lot more we can do with ControlP5. The goal today here is not to do like an exhaustive demonstration of all the possibilities, but just to kind of give you a taste of what this library can do and how you might use it in your own projects. Cool. All right. So let's move on from ControlP5, unless you guys may have some questions about what we're doing so far. Any questions about ControlP5 or libraries, or is it kind of making sense? All right, let's move on. Okay, I'm gonna bring back my browser window. Where to go? Here. Okay, let me go back to the processing website. We're gonna go find the last library we're gonna look at today. Under libraries, it's gonna be under simulations, and it's called Fisica. It's a little physics library, which is pretty neat. You'll see there's lots of different ones. There's one called Box2D that's very popular as well. That's used in several games actually. Both of them are libraries that are wrapping around the same library. That's another thing I want to point out also. A lot of these processing libraries are gonna use this word wrapping, right? A wrapper. So what that means is there is a Java library called JBox2D. This is a pretty complex library. It's used in it's a Java physics engine. That's what it looks like here. And it's used in a lot of games. That library in of itself is a port of Box2D, which is used as a C++ library that's used in a lot of projects also. And the trick with those Java libraries is that they can be difficult for people who've only learned processing to kind of get into, because they rely on some knowledge that is part of the bigger picture. When we learn Java as a language, it relies on things that we kind of leave out when we teach processing, not because they're too hard, but because we tend to not have time to get to them, and they're not really necessary to focus on the basic of programming, to learn the basic ideas. It just gets in the way. So if you want to dive into Java libraries, then really quickly you're going to run into some issues, because there's going to be some gaps in your knowledge. So what a lot of these processing libraries end up doing, you see here there's 3 different ones. There's Box2D, Fisica, Liquid Fun, there might be another one, is they end up being wrappers for existing Java libraries. And what a wrapper means is that the author of the library has kind of created this layer between that uses the Java library underneath it, but then presents it in a more digestible way and an easier to use way. So both of these, Box2D for processing and Fisica, are both using JBox2D under the hood, but they have different approaches in how they will present that to the programmer or the user of the library. And I quite like the way Fisica approaches it, because it's very simple and kind of easy to get started, and it hides some of the complexities of JBox2D. So you don't have to worry about them when you're first learning about these physics libraries. So let's take a look at that reference page, and then you'll see, again, different aesthetic, right? Different way of arranging things, a bunch of examples, and a little bit more sparse than ControlP5 already. And then a documentation page using this Java doc format. So something you can expect from library to library is essentially the lack of, they're not all going to look the same. They're all going to be done in different ways, so you have to learn their little details and particularities. Okay, so let's bring up the library manager. And so if you wanted to install Fisica, it's also available here in the library manager. You would search for Fisica, then you would install it. Of course, I already have it, but if I didn't, I could click install, it would download. So let's see what we can do with the Fisica library. We'll just do a couple of quick examples, just to, again, give you a taste of some of the possibilities and whether or not you might want to use it in a project, either for your game or in the future. Okay, so I'm going to start a new sketch here. And as usual, need some kind of size. I'm going to go import library under a sketch menu. Even though you can't see it, I'm doing import library right now, and I'm adding Fisica. And when I do this, it just adds this line. So just like with ControlP5, it says import Fisica.star, which means take all the objects that come with the Fisica library, bring them into this sketch. So Fisica has a slightly different pattern than ControlP5, but there's some similarities as well. So in ControlP5, we had this ControlP5 sort of master object. In Fisica, that object is called an F world, and we're going to call it world. So this class, this type here, comes from the Fisica library, right? So this is an object that we imported from this Fisica package. So in the world of Fisica, the F world is the master object that's going to control all the other objects inside that we bring in from that library. In ControlP5, it was the ControlP5 object that sort of was responsible for overseeing all the buttons and the sliders. In Fisica, that object will oversee all the boxes and circles and things we add to this physics simulation. Now, the Fisica library has a slightly different twist to the way it gets set up in the beginning. So when we create the world object, we're going to say world equals new F world. But this one doesn't want any parameters. There's no reference to our sketch. Instead, the approach that Fisica takes is it has this hidden object that we don't get to see. It's what's called in Java, that's called a static object. So it doesn't need to be created. It's kind of this, it's like a omnipresent godlike object that we can just access. And it has an init function, and the parameter to that init function will be a reference to our sketch, to the p-applet, right, which is our program. So these two lines together kind of initialize the Fisica library, and it will be different for every library how they choose to do things. The way you would find out about this is by essentially just opening some examples that come with it, and then looking at what is the code doing. This is why also practicing, reading code, and the test, the quiz, and the midterm, I sort of give you some code reading exercises. Is that being able to do that is really important, because once you move beyond like the basics we're doing in this class, you want to do more interesting things, you're going to have to spend some time reading programs to figure out how things work. Now I'm just kind of cutting to the chase for you, and because I prepared for this and I know how it works, but in practice you would have to seek this knowledge out on your own, and you can usually piece it together by just looking at the examples. That's the best way to do that. Okay, so in Fisica we have this fWorld object, and one of the cool things about Fisica is that we can create objects and it will animate them and draw them for us. So for example, one of the objects we can create is something called an f-box. An f-box, as you can imagine, is some kind of rectangular shape. So we'll say new f-box. And we give it a size when we create it. So let's say I'm going to make a box that's 100 by 10. So this is a width and height. And then we'll say add this box to the world. So we'll say world.add box. Okay. So in that way, the world object kind of behaves like an array list a little bit. So we're going to be able to add things to it, and it's going to take care of just sort of orchestrating everything for us. So all right, so we can add an object to the world, and then in our draw function, we're going to, let's say, make a white background, and then we'll say world.draw, and that's going to take care of drawing. So you can kind of see at the top left here, there's a little box that appears. That's going to take care of drawing all the objects we've added to this world, this sort of simulation, automatically. And then if we wanted to animate, we will also tell the world to run its physics simulation, which is done by using the step function. So that's going to move the simulation one step further. So if we added the box to the world and the world.draw and world.step, we can see this black box that's falling over. Now, these objects, we can really configure them and change them. So I can do things like, I'm going to set a position for this object, a starting position that's going to be in the center of the screen, right? So now it's falling over there. It also has visual things we can change on it. We can set the fill, for instance. I'm going to make it black. You can also do things like attach images to these simulated objects, so you don't have to draw them necessarily as boxes and ellipses and things like this. They can also have images attached to them so that they become more like sprites in a game. And the other cool thing that happens is it's hard to do. They can also be dragged by the mouse by default. Now this one is a bit hard to catch because it's just falling off. So one thing we're going to do is we're going to add some edges to our window. So we'll say set edges on the world, and that's going to create these 4 boxes. You can see they're hard to see because they're black, and my background of my stream is black, so you can't see them. But now there's an edge on the bottom, and there's an edge on the left and on the top, and it's easier for me now to pick up this box I created. And you can see this pretty neat because it's like it's a physics simulation. So if I grab the object and move it and release my mouse, it will fall down. And if I grab it by its corner, I can like spin it around. And all of this is being calculated by world.step. So this is all part of the Fisica library and what Fisica brings to the table within our sketch. So we don't have to do, be math wizards and figure out how to do these complex calculations for the motion. We already did our simple motion equation, which for some things is pretty good, but when you want to have more realistic motion or physics or physics-driven collisions, like things can get hairy very quickly. So relying on libraries becomes pretty much a necessity. So within Fisica, objects kind of exist in this simulated world. you can tweak things like the gravity and sort of the viscosity and the amount of resistance that's in the air. So obviously it's not totally realistic. It's kind of like being in this on the moon or something. It's gravity is pretty low right now, but still fun to play with. So we can add some objects, and yeah, once we create objects, we can manipulate them. So with the F box, we could set its position, set its fill color, for instance. All right, and then we'll see we can also get objects to interact with one another. So for example, we could add some circles. Okay, so we're going to, in draw here, over time, I'm going to say every 60 frames, let's say. So when frame count divided by 60, when the remainder is 0, right? So we know how to do this. When that happens, we're going to create an F circle object. I'm going to call it C. So F circle, as you may expect, is kind of like a box, except it's a circle, and it needs a size. So we can make it random, maybe between and then we'll add the circle to the world. Oh, sorry, not for. That should be an if. My bad. Forgot a parenthesis. Cool. So those guys are kind of off on the side here. So I'm going to set their position. To be at the top as well. And then you'll see that they interact with each other, right? So I have the my box object can interact with them now, and the circles can also interact with one another. Oh, actually, someone at the door, guys. Just give me 1 second. I will be right back. Sorry about that. This cool. All right, circles are kind of piling up here. Yeah, so it's pretty neat how with Fisica we get some really good collision detection. If you try to program that from scratch, that would be pretty hard to do. So for some of your games, you might want to think about how you could leverage some of the things that Fisica can do. The trade-off is, of course, you have to learn how to use the library and learn how to work with its objects. But it can be well worth the time spent, just in terms of the kinds of things you are able to do once you learn these libraries. Let's tweak this program a little bit more. Once we have the ball objects, for example, we could say these circles here. By default, every object in the world you can click on, right? If I click on, I can grab it. So I can move the object around, and maybe we don't want to do this. So I'm going to make it so that only the box can be dragged, but not the not the circles. So there is a it's called grabbable. Let's say set grabbable. Wait, how do you spell that? Yeah. And then we'll say false. So now if I run the sketch, I can no longer grab the circles. I can only grab the ball at the bottom. So maybe we'd want to make a game where we have to like clear the bottom, like make sure nobody hits the bottom or something like this. So we could get rid of the walls as well that are on the side. For example, I might want to remove the top wall, the left wall, and the right wall over here. So that's going to get rid of the side walls but keep the bottom one. So now I can actually get rid of those guys and kick them off the screen if I want to. And of course, you know, the set fill, that could also be a color. So it doesn't have to be gray values. It could also be you know, they could be green circles, or I could attach an image to them or something like this. So lots of fun things we can do with the Fisica library. Now, once these objects are added to the world, this F world, you kind of lose track of them a little bit. So if, oh, where's my, oh shit, I threw my box off the window, threw my little paddle off the side. So let's give those a random starting coordinate instead, so they don't all just pile up awkwardly. So once you add objects to the world, you kind of lose track of them. So once you've added an object to the world, right now we don't have any way of changing it later on or asking questions about these objects. So we could also do an example where we can keep track of the objects we're adding to the world in our own array list, as well as adding them to the world to see what that would do. Or yeah. So that gives you an idea of what Fisica can do. How are you guys doing over there? Because obviously it's kind of hard to ask questions in the chat. Would you be interested in doing another Fisica example, or are you getting bored of this already and you kind of got all that you need to know? I'm happy to do another one, maybe where we could do like a grid of boxes and talk about doing a grid layout or something like this. That could be interesting. Only if you guys are up for it. Otherwise, we can also we can wrap up as well. So, let's see if anybody is still here. Oh yeah. All right. So please let me know in the chat if you want to do one more Fisica example, or if you're hungry and would rather go to lunch. Yeah, Priyanka, yes, of course, you can use any other variables. So with the ControlP5 example, these are just ones I made up, right? So if you created a slider and you wanted to control any variable in your code, you would just give it the same name as that variable. And here I just, to do that little demo, I created a button called pump, and then I made a function called pump to connect it to it. But you can use whatever names you want, right? So it doesn't have to be, and you can, if you create multiple buttons, if you give them each different names, then you can have separate functions in your code. So it's a way to create your own events, right? All right, cool. We will do one more. Absolutely. Happy to do that. Okay. So let's do another Fisica example. I'm going to get rid of some things here. Not everything. Just give me 1 second. Kind of lost in all my different windows that are open that you guys cannot see. All right, let's do one more. So we're going to keep the edges and all that. So these, by the way, so what happens is once we add the edges, right? All Fisica does is it creates these rectangles that are positioned on top, left, right, and bottom, and we can access them using the fields of the fWorld object. So here, this is removing a particular object, but this could also can be used the same way we have with the ArrayList. We could also remove boxes later on, or circles, once they're added to this big bag that's the world. This gives us a handle to say this sets all 4 edges by default, and then we can get rid of the ones we don't want for whatever reason. If we don't necessarily want to be boxed in, if you just want to have a bottom floor, you can remove these walls by using the remove command. All right, so let's get rid of this. Let's make a fun little simulation. We're going to create like a grid of boxes, kind of like a bunch of platforms, and we're going to talk about how we would do a 2D layout. You know, maybe you're making like a tic-tac-toe game or something, and you need to do something that's in a grid. So we'll talk about how we would do that, and we'll make those platforms, like we can make them spin or something. We can get them to rotate, and then we'll have some we'll make some balls fall through them to kind of create this like demented pachinko machine or something like that. Let's see what that would look like. All right, so the first thing we'll do is we're going to create a whole bunch of boxes. So we don't have to make objects individually. We can also use for loops to do that. And whenever we want to do something in a grid kind of layout where we have rows and columns, this is typically this is going to be a good candidate for using the nested for loop concept. Okay? So we're going to create a for loop that's going to do the columns, and another for loop that's going to do the rows. And let's say we want to do a 10 by 10 grid. We're going to write a for loop that repeats 10 times. Okay. So this for loop here is going to repeat 10 times. And then inside of it, I'm going to place another for loop that's going to repeat 10 times. And I cannot use I again, so I'm going to do the next best thing. I'm going to use J. So now I've created these nested for loops. And the inner for loop is going to get repeated by the outer for loop. And the result is this grid-like pattern, right? So the I counter is going to be the columns, and the J counter is going to turn into the rows. So what I'll do is within the for loop, I need to do something with I and J that are just going to be sequences of numbers between 0 to 9. Okay. So let's create some X coordinates and Y coordinates. So we can use map to do this very easily. We'll say map I, which goes from 0 to 9. Let's map this to a value that's between, let's say, 0 and width. Okay. And then let's map Y. We're going to use J, and then we're going to map it from 0 and height. And then we can use this to create a bunch of boxes. So these boxes, they're going to be like, let's say 40 pixel wide by 5 pixel tall. And then we're going to set their position to be XY. Then we'll say world.add B. And of course it would help if I spelled world correctly. Okay, cool. So now, oh, that's interesting. Okay, so you can see when I run the sketch, it created all these boxes in the grid, but now because there's gravity, they're all falling down and creating these little stacks down there, which, you know, is kind of cool actually, but it's not what I want to do. So what we're going to do is we're going to tell these boxes to not move. So we can do that. There's a command called set static, and we'll set it to true. And the default, this is going to make them fixed. The default is false. Okay, so if things are not static, so now something is static. It's like I can move it, but it's not being affected by the physics. So the gravity, and it's not bouncing into other objects. It just becomes a, if you're making, like, let's say a platformer game, right? Your platforms are static. You don't want them to fall down because of the gravity. So now my objects have been laid out, and they have this static option, whereas if I didn't put that in, now they're affected by the simulation and they fall down, make these stacks. I don't know why that one always falls, tumbles over. Interesting. Okay, and let's make them black too. Fill black. Cool. And then we can also give them like a rotation, set rotation. So now this is going to be in degrees. So if I go, let's say like 45, this is going to create 45-degree angles. Unlike with rotate in processing, which is in radians, this is in degrees. So we can say, let's get a random angle. So they're all like all over the place. Cool. So, all right. So now we've made a grid of these F boxes, right? So I'm in setup, right? We use the nested for loops to create columns and rows, right? So the one for loop repeats the others, and the effect is we end up with all the combinations of these two counters, right? So we'll get kind of like a series of coordinates out of this. We'll get 0, 0, then we get 0, 1, 0, 2, 0, 3, all the way to 0, 9. And then it goes to the next row. It's going to go 1, 0, 1, 1, 1, 2. So that gives us like the 100 combinations of I and j, right? And because these are only between 0 and 9, I can use map here to get more useful coordinates out of them. So I want this to be spread out across my window, or maybe we can tighten this a little bit so that they don't go all the way to the edge, because some of them get clipped a little bit. So I'll just change the boundaries. Okay, so now they're more contained within the window. So this is pretty fun. Now we could say, if we wanted to play with this, right, we could go and we don't have to do anything in draw, because all the work is done by the physics library. Once we give it objects to animate, it draws them for us and it does all the animation for us. So we could say, let's add some objects into this world we created. I'm going to go mouse pressed, and we're going to create an F circle. Let's see. And we want them to be probably kind of tiny. Let's say 10. And we're going to set its position to be wherever the mouse is. So when I click here, I'm going to be adding this F circle. Let's give it a color to, say, green. And what else can we want to do? We'll say set no stroke, and we'll say set grabbable false, so we can't grab them. Grabbable false. And then once we have this F circle object we made, we're going to say add it to the world. World.add C. So now what can happen is when we click, whenever I click, I can now add these, actually these are a little bit too small. I can add these circles under my mouse cursor. Sometimes, depending on where they appear, they seem to be missing that first one. I don't know why. So it's not, the physics engine is actually not perfect. Sometimes there's some little mistakes in it, but overall it's fairly reliable. And now they're going to fall down according to whatever random series of boxes were created, or we can make those a little wider maybe. Are they gonna get trapped? No, they can fall. Cool. All right, Nathan. There's going to be plenty of time to look at the trailer in a few minutes. All right, let's do one last thing, because that could be interesting if you end up playing with Fisica. So now, let's say we wanted to interact with these objects after the fact. Maybe we wanted these, now I can move those, so there's that, because that's just kind of a default behavior of the platforms. If I click them, I did not set grabbable to false, so these can be grabbed. If I want to, I can move them around. But let's say I wanted to program the behavior for these platforms. Maybe I want them to kind of continuously spin or something. Once I've added an object into the world, I no longer have like a reference to that object. They're all just part of this big bag called the world, and I can add to it, but then it's hard to then get back to those objects afterwards. So one thing we can do is we can say, let's keep our own array list of f boxes, so that we can keep a tab on which boxes we've added, and if we need to access them later, we'll have a place where we can find them. Okay? So I'm going to make this array list of f box objects. It's just a new empty array list, and as we add boxes to the world, we're also going to put them at the same time into our own list. So this the world has everything, right? And the boxes array list has only the boxes. And what that's going to allow us to do is say in draw, now we might want to do something like this, where we can say go through all the boxes, right? And then we could get their rotation, right? That's going to give us the current angle, and then we could move them by, let's say, increasing that angle by 1. Okay. Whoa, too much. Okay. Too much. 0.1. That's still a little bit intense. 0.05. 0.01. Okay, that's better. So now we have a way that once we've added objects into the world, right, what we do is if we want to refer to them later on, what we have to do is keep tabs on them. And one way that we can do that is put them, if we only had one object, we would create a global variable for, let's say we're programming a asteroids game and we want to keep track of our paddle, we would make the f box a global variable. Or if we have many, we can put them into our own array list. And what we're doing here is just kind of keeping tabs on our objects, saying once we add them to the world, they kind of go into this big bag and they get mixed in with all the edges and all the other objects that will get added later. So let's keep our own list separate. This only has the boxes. And then that allows me to then go back and do things like this, where in the for loop, in draw, I'm writing a for loop that goes through all of them and increases their rotation, so that we can animate them or give them our own behaviors in addition to the ones that the physics engine is programming already. Or if we wanted to go and change their color or something like that when something happens, we would have a way to access them. Okay. Cool. All right. So that's about it for Fisica. I think there's one more example posted in D2L, but we've been here for an hour and a half, so I'm sure you guys have had enough. And there's only 14 of you left, which is not bad, I would say. I'm kind of impressed you guys all even showed up on this Friday afternoon for the makeup class. So thanks for checking in, And yeah, if you need to refer to this later on, I guess YouTube will be recording this anyways. You can access the recorded version of it on the same channel if you want to review it for whatever reason. If you want to use some of these libraries in your code, you can watch this again. Otherwise, I guess we'll call it a day for today. I will be sending an email shortly later this afternoon about times for next week. I'm sure you'll all be working on your projects. I'll basically be around all day from 9:30, 10-ish until 3:30-ish on Tuesday and Thursday. So rather than have bookable office hours, I'll probably just be in the makerspace. I'll send an email, like I said, just so you have a reference, but I'll be around for those 2 days, and then I'll also have a day the week after that. If you just need some help working on your projects, I'll be around to give you a hand. And yeah, one more time, if you didn't make it to Meta, try to head over sometime this weekend. You can just hop on the St. Clair streetcar. It's pretty easy to get to. And otherwise, have a great weekend, everybody. And I'll see you next week. I'll stick around for like a minute or two in case anybody has some questions, because there's a delay on the video. So, and if not, I will sign off. All right. Take care, guys, and see you next week.